Okay, so far you know two rules on finding derivatives. You know the power rule and you know the product rule. Now we're going to talk about the quotient rule. How do I know I'm going to use the quotient rule? Quotient means divide. So anytime you have a division problem or a fraction, you know you're probably going to use the quotient rule. Sometimes those can be rewritten and you'll use a different one. But that's kind of your clue on when you're going to use the quotient rule. Here's what the quotient rule would look like in your book. Okay, so let's look at it and see if we can figure out what it's saying. First of all, d over dx, that's just saying find the derivative with respect to x of two functions. My f of x functions on top, my g of x functions on bottom. So here's what it looks like. So they're saying take my bottom function times the derivative of my top function minus, my top function times the derivative of the bottom function all over that bottom term squared. So this is what it would look like in your book. Let me get rid of that little thing right there. Okay, that's what it's going to look like in your book. Here's what it would mean in real words. Bottom term times the derivative of the top minus the top term times the derivative of the bottom all over the bottom term squared. Or sometimes you'll hear this. Low d high minus high d low, cross the line and square the low. So what does that mean? Low term times the derivative of the high term minus the high term times the derivative of the low term. So d low means the d stands for derivative. Cross the line. So draw a line, cross the line, and square the low term. So low d high minus high d low, cross the line and square the low. All right, so let's see what this looks like. Here's example one. So first of all, I know that this is going to be the quotient rule because I have a fraction. I have a top term, I have a bottom term. Okay, so let's find the derivative. There's lots of ways you can remember it. Low d high minus high d low. So low means my bottom term. Low d high, so that means the derivative of my high. So the derivative of 5x minus 2 is 5. Minus, so low d high minus high d low. So my high term low d high minus high d low. So now I'm going to take the derivative of my bottom term. Derivative of x squared plus 1 is 2x. Cross the line and square the low. So I'm going to take my bottom term and square it. Now, my rules will be, again, if it can be easily simplified, go ahead and simplify it. If you have to start foiling a bunch of stuff out, you will do that. On this bottom term, you will never square this out. You'll always see it left as a quantity squared. So let's go ahead and fix the top though. I'm going to distribute my 5. So when I distribute the 5, I get 5x squared plus 5. Now I'm going to distribute this 2x and that negative at the same time. So I have 2x times a negative 5x, that's negative 10x squared. 2x times a negative 2, but then I'm also distributing that negative, so that's going to make it a positive 4x. All over my bottom term squared. Remember, we're always just going to leave that as something squared. And I'm going to combine like terms. I have a 5x squared, negative 10x squared. That gives me negative 5x squared plus 4x plus 5 all over my bottom term squared. And that's the quotient rule. Low d high minus high d low, cross the line and square the low. Okay, let's do another one. Okay, example 2. Again, I know it's the quotient rule because I have two things being divided. Okay, I have two terms, a top term and a bottom term. I can't simplify it at all. So f prime of x, low d high. So my low term times the derivative of my high term. So that's going to be 3x squared plus 5. So low d high minus high d low. So my high term times the derivative of my bottom term, which is 2x, all over my bottom term squared. So 1 there, by the way. Okay, I could go ahead and distribute my 2x. I could FOIL this out. For right now, we'll just leave it like that. Now remember, if you're checking your answers in the back of the book, it's probably not going to match up because they're going to simplify as much as possible. Example 3. Okay, again, I know that it's the quotient rule. I can't simplify it all. I can't rewrite it. So I'm going to have y prime equals low d high. So my low term times the derivative of my high term, 3x squared plus 4x. So low d high minus high d low. So my high term times the derivative of my bottom term, all over my bottom term squared. So again, low term times the derivative of my high term minus my high term times the derivative of my low term, cross the line, and square the low term. Again, we could FOIL this out, combine like terms. Okay, but for right now, I want to make sure you know how to do the quotient rule. Okay, let's do another one. X squared plus 7 over the quantity 2x minus 7. Y prime equals low d high. So low term times the derivative of my high term, 2x. So low d high minus high d low, my high term times the derivative of my bottom term, cross the line, and square the low. Now this one's easily simplified. I don't have to FOIL anything out. I'm going to go ahead and do that. So I'm going to distribute my 2x. So that's going to give me 4x squared minus 14x. Same thing here, I'm going to distribute my 2, and I'm also going to distribute that negative at the same time. So that's minus 2x squared minus 14 all over my bottom term squared. So when I simplify and combine like terms, I get 2x squared minus 14x minus 14 all over 2x minus 7 quantity squared. I don't know what's wrong with my marker. Okay, and even though I could factor out a 2 here, we're not going to do that because it's not going to do any good. Nothing will cancel, so I'm going to leave it just like that. Okay, I think we have 2 more examples. Find dy dx. Okay, so again, I know it's the quotient rule because I'm dividing. So y prime equals low d high. So the derivative of x is just, oh, I'm sorry, low d high. So my x term, my low term, times the derivative of my top term. So the derivative cosine is negative sine x. So there's my low d high minus high d low. So cosine x times the derivative of the bottom, which is 1, all over my bottom term squared. So low d high minus high d low, cross the line and square the low. So I'm going to kind of fix this. This is x times a negative sine x, so I'm going to bring my negative out in front. And leave it just like that. You're not going to try to cancel any x's because that can't happen. And there's your answer. I think we have one more. Okay. The other type of problem that you're going to have in this assignment is sometimes you're going to want to find more than just the first derivative. Here are the symbols that you'll find in your book. Y, and with these little 2 quotation marks, means to find the second derivative. This means to find the third derivative. This would mean to find the fourth derivative, and so on. Why would we ever want to do that? Well, one way that we've already seen is sometimes we have to find the derivative of position and find velocity, but then we have to find the derivative again to find acceleration. So we just find the derivative 2 times. So in example 6, we want to find the second derivative, which means we're going to find the first derivative and then find the derivative of that. So let's find y prime. Y prime equals, this time we're just using the power rule. Bring down the exponent, subtract 1, plus, bring down your exponent, subtract 1, minus, bring down your exponent, subtract 1, minus, derivative of x is 1. That's my first derivative. Now I want to find the second derivative, y double prime. And that's what I'll call that, y double prime. We're going to do it again. Power rule. 4x cubed, derivative be 12x squared, plus 12x minus 6. Derivative of 1 is just 0. Oops. So that's my answer. Okay, your assignment is written on the Blackboard page. That's what you will work on tomorrow in class, and I will see you Wednesday.